before we do the first example, we want to make sure that we are getting to know the mean value theorem. We want to recognize important pieces of it so that we can look for key ideas in this example problem to compare to this theorem so that we can use it to prove what we're asked to prove. So notice that we are given some information. We need a function. In this case, it happens to be called f of x. We need that function to be continuous and differentiable over an interval. Now, it could be continuous and differentiable everywhere, but we need it to be at least differentiable on this open interval from a to b, and we need it to at least be continuous on the closed interval, those are brackets, a to b. So number one, we're going to have to, when we see a mean value theorem problem, we're probably going to have to try to figure out what a and b are. And notice a and b, they're input values, they're x's. They're domain values. So we need C. We're going to try to prove, we're going to use the mean value theorem as our proof that some C exists. C is also an input value, a domain value, an x value, and it has to be in between A and B. And if we have all the things that we need, if the hypotheses of this theorem are met, then we can conclude the mean value theorem is enough to prove that there's some C where f prime of C, the derivative of f at C, is equal to the average rate of change over the interval from A to B. All right, so look at this first problem. Let f of x be a twice differentiable function such that f of 2 is 5 and f of 5 is 2. Explain why there must be a value C, 2 is less than C, which is less than 5, for which f prime of C equals -1. So here, don't expect this to happen. I'm warming you up. But this was an actual AP test problem. So can you see already, they've even used the same letters that we sort of memorize in the theorem. C is some value. It needs to be between A and B. So this is our hint right away that A is going to be 2 in this problem and B is 5. So, and we're going to be asked to prove that there's some place where f prime of C equals something. In this case, we've been told we need f prime of C to equal -1. This is easier than it looks. So what do we have here? We know C, it happens to be that our function is named f, so we don't have to worry about changing the function name from what we may have memorized in that theorem. So do we know that f is continuous? Well, look, f is twice differentiable, and a differentiable function, a function is only differentiable if it's continuous. So we know f is continuous. Do we know f is differentiable? Yes. In fact, we know that f is differentiable and its derivative is also differentiable. That's going to be more important later. So the two hypotheses of the mean value theorem are met. We know that f is differentiable and f is continuous. It turns out f is differentiable and continuous everywhere because we haven't specified a domain. We only need it to be those things on this interval from A to B. And we have an idea already, just because of the wording of the problem, that we're going to have A equal to 2 and B equal to 5. So let's see what else we know. The one thing that the mean value theorem is really good for is telling me that there's some value C in between A and B for which f prime of C, which we know is -1, has to equal the average rate of change. So that's the only work we really have to do here, is we need the derivative at C, which is -1, to equal the average rate of change of f on the interval A to B. And that is f of B minus f of A over B minus A. But I have already got this idea about what A and B are. B is 5, f is 2 over 2. So really in this problem there's going to be two things to do. Number one is just to prove that this math turns into a true statement. And number two is going to be to give a write-up using the mean value theorem. So I'm just going to do a tiny bit of calculation to show -1 equals, what is f of 5? 2. What is f of 2? 5. My denominator is 5 minus 2. And what is 2 minus 5? That's -3 divided by +3, which does in fact equal -1. So I had to check that that was going to be true. Now I'm going to give a write-up using those words from the mean value theorem. I'm going to highly recommend that you copy this exactly. I'm going to actually use the typing feature and type it out so that you see all the words exactly as they are, and start to build this habit of writing up a mean value theorem problem like this. So I'm going to read what I wrote. It said, since f is continuous on the closed interval 2 to 5 and differentiable on the open interval 2 to 5, the mean value theorem guarantees that there is at least one c is between 2 and 5, for which f prime of c equals -1. So a couple things to notice. Yes, you are welcome, you're welcome to use the MVT. It's an understood abbreviation for the mean value theorem. Also, this part here, f prime of c equals -1, you would not have had the mathematical right to make that statement if you hadn't already shown me this work up here, that you found f of 5 minus f of 2 divided by 5 minus 2, and done that work to show that it was already equal to -1. Some people who like to write as little as possible could have, instead of doing this work here, you might have started with this statement, and then here at the end, instead of writing -1, that's where you could have shown that calculation, f of b minus f of a over b minus a equals -1. So in that way, you're writing one sentence. If you feel like that takes less work or uses less space, you're welcome to do that. But you have to have shown me these two things. Number one, that you computed the average rate of change using an appropriate a and b, and that the result was actually equal to this, and that you've written this write-up. Number one, convincing me that you actually checked the hypotheses. You have to check that f is continuous and differentiable on the interval you're using. And you have to then use those words from the mean value theorem to make that statement, that the mean value theorem guarantees that this c value that you're looking for must exist.